So there are lots of ways. Wait a minute, what am I doing? Hello, everyone. Thank you for joining me. So there are lots of ways where we can graph a piecewise function in lots of different ways. But I think since we're just working with piecewise functions that consist of linear components, in other words, every equation you see over here in Math 121 is going to be a line, then the easiest thing is just to use our old school tactic of finding 2 points, one of which might be a hollow point, and plotting the graph. So let's look at this one step at a time. We've got the first piece, y equals negative 2x. It is confined between negative 4 and negative 1. So let's just plug a negative 4 and a negative 1 in and get 2 points. Kind of get the end points of this piece. So negative 4, negative 1. Negative 2 times negative 4 is 8. And negative 2 times negative 1 is 2. And we're going to get an ordered pair at negative 4, 8, negative 1, 2. We got, oops, kind of went over it here, but check it out. We've got an equal to here, but we don't have an equal to here. So this one's going to be solid, and this one's going to be hollow. Everyone cool with that? The solid points directly correspond to the equal to, and the hollow points directly correspond when you don't have the equal to. So negative 4, 8, got your point right here, and negative 1, 2. Got a hollow point right there. Let's connect the dots. If it helps you, you can use the fact that the slope is negative 2 and go down 2 over 1, down 2 over 1. Yeah, that really helped me a lot. Let's see here. My shadow is right in the way. Okay, got it. That's the first piece. Let's erase our work over here. You can always rewind it if you need to see it again. And let's do the next piece. Oh, you know what? The next piece is just a horizontal line that goes between negative 1 and 5. Now the horizontal line is down here at negative 6. You can see I just put a little mark there. And we're just going to go between negative 1 and 5. So negative 1 all the way to 5. You see, if it's a horizontal line, we might as well just draw it in there like that. I can't leave it like that, though. I need to decide whether it's hollow points or solid points. Looks like 2 solid points. Boom. Boom. Got it. Okay. This last one looks kind of nasty. And you'll notice that the inequality just has one part to it. X is greater than or equal to 5. Now that means that one end is going to have an arrow and the other end is going to have a point. But we still need 2 points. So check it out, everyone. Y equals 3x minus 12. Now, I'm definitely going to put a 5 in here to see what that gives me. And if I put a 5 in, 3 times 5 is 15 minus 12 is 3. So if I put in a 5, I do get a 3. Now I'm going to put in one more number because I need 2 points if I'm going to draw the line. I'm just going to use the next x value. We're working the values that are just bigger than or equal to 5, so I'm just going to plug a 6 in. Where did I get 6? Because 6 is bigger than 5. Plug a 6 in there, it's 3 times 6 is 18, minus 12, yes, you do get a 6 out also. All right, let's green this one on the graph. So we got 5, 3. That is a solid point right there. And then we got 6, 6, which is also a solid point, but that's not the end of the graph. Because we don't have 2 sides to this inequality, since it's just a single inequality, not a compound inequality, this one actually keeps going. So after you get to this point, you've kind of established the line you're drawing. You just need to put an arrow on it to show it keeps going forever and ever and ever. And that will take care of that graph. By the way, whenever you draw a piecewise function, take a moment when you're done to make sure that it passes the vertical line test. Whoops! I do not pass the vertical line test here. I made a mistake. It's a good thing I did that check. Well, it looks like here someone wrote a bad function. Someone put an equal to on both of those. Those can't both have equal to's. So I bet what happened here was someone who wrote this equation really meant for one of these not to have an equal to. So let's fix it. Instead of saying x is greater than or equal to 5, this should say x is greater than 5. Good. This should say x is greater than 5 because we can't have an equal to on the 5 for both equations. That means we'll go ahead and change that to a hollow point. Okay, so obviously someone made a mistake when they wrote this. It could have been Steve. It probably was Steve. Thanks for watching.